Okay, 10.6 is going to be talking about circles and arcs. So definition of a circle is a set of all points equidistant from a given point called the center. So A is our center. And if you look, you have P being a point on the outside, Q, R, S, and they're equidistant, which means that all the distances are the same. And we name a circle by its center. So you could say circle A, or you could say, kind of draw the picture here to create that circle A. Diameter and radius. So diameter is a segment that contains the center of a circle and has both endpoints on the circle. So it goes all the way across. Okay, a radius, so an example of that would be RP, the one I just drew, or PR, so the opposite direction. Okay, it has to go all the way across. A radius is a segment that has one endpoint and another endpoint on the circle. Okay, so a radius is just part of that. So we go, one example would be like AP, another could be AS, another could be AR or RA, another could be QA. Okay, so it goes from the center of the circle to a point on the outside. Congruent circles. Congruent circles are circles with congruent radiuses. Okay, so radii is radii. So if DO is 4 and RA is 4, that means our circles are congruent. And we could write either circle O is congruent to circle A, or you could draw the picture of circle O being congruent to circle A. But they have to have the same radius. Okay, central angle is an angle whose vertex is the center of the circle. So vertex, remember, is the letter that sits in the center here. So you can see that A is in the center of all of those because it's the vertex. So SAR, A is your vertex, SAP, so this big one here, A is still your vertex, okay? So it's a central angle. Arc and semicircle. An arc is a part of the circle. A semicircle is a half-circle arc. The measure of a semicircle is 180 degrees, named by the endpoints at another point. So ACE, okay, is a semicircle. If you look, it's half of that circle. Okay, so then if I want to say the degrees, that means this or this is 180 degrees here. Okay, another example is CED, so I'm going to erase that. So we got CED. So it would include this entire arc, and you can see that it creates that half portion again. So it should equal 180 degrees. Okay, a minor arc. A minor arc is a smaller than a semicircle, so you name by its endpoint. So SP is not a full, like half of your circle. Okay, another example could be this one here, so SR, okay, or RS, okay, it's not an entire half of your circle, it's a minor arc, it's minor. So the measure of a minor arc is equal to the measure of the corresponding central angle. So if this is 20 degrees, then the measurement of that minor arc would be 20. In the example given, if this is 50 degrees, then the measurement of this minor arc is going to be 50. Major arc. A major arc is larger than a semicircle, so this time it's going to be bigger than half of my circle. So we name by its endpoints and another point on the circle. So the example given, one of them is PQS. Okay, so you can see that that is larger than half of the circle. It is also not a minor arc because minor arcs are smaller than half of the circle. Okay, the measure of a major arc is the measure of the related minor subtracted from 360. Okay, so if we have this minor arc, so TQR, we're trying to find this entire thing. So if I have the minor arc, this being 50, all we take is 360 minus that minor arc to get the measurement of our major arc, which is 310. So 360 minus 50 gives us that 310. Adjacent arc, so adjacent means sitting next to. So adjacent arcs are arcs of the same circle that have exactly one endpoint in common. So the arcs that sit next to each other. Okay, so BC and CD are adjacent arcs. They sit next to each other. Arc addition postulate. The measure of the arc formed by two adjacent arcs is the sum of the measure of two arcs. So if I have ABC, I could add AB and BC to get the whole measurement. What is the measures of each arc? Okay, so PR is this one. So we have the one sitting across from it being 77 degrees, so we know this is going to be 77. Okay, RS let's change colors, is this one. Well, if you look, this creates a 180 degree line. So if we need to find this, let's take 180 minus 77 to figure out what that is across from it. So 180 minus 77 is 103 degrees. These should have degrees on them, sorry. And then we got PRQ. So PRQ, this whole thing. Okay, so if this portion is 28, we know this is also 28. So we can add all of that 77 plus 103 plus 28 to get that full length. So that full length is 208 degrees because we had to add all those together. Okay, and then my last one here is PQR. So this direction. Okay, so we know this one is 28. We know this one is 103. We need this one. Well, if you look, this creates, if you can see it, creates a 180 degree line. So if I take 180 minus that 28, I'll get what's left for this, which is 152. Okay, and so now we got to find that full purple length. So I got to take 152 plus 28 plus 103. And I get 283. So we get 283. Okay, arc length. Definition. A fractional part of a circle or circumference. So the arc length of a semicircle is half of the circle's circumference. Okay, so we're going to take whatever that arc measure is divided by 360 times the circumference. So let's go back and talk about circumference. So the equation for circumference is C equals 2 pi times your radius. Okay, so that's how we're going to have to find the circumference. So we're taking our arc measure, 240, divided by 360 times the circumference. So the equation 2 pi r. Well, we know our r because our radius right here is 15, so let's plug that in. So 2 pi times 15, so times 2 pi times 15. So let's simplify. Let's find 240 divided by 360 first. So it is like 0.67, and then we're going to times that by 2 pi times 15 to get 62.83 degrees.